Think of any refinery as a giant chemistry set, performing 4 basic tasks: distillation, hydrocleaning, cracking, and blending. Each stage is designed to create more exact and more pure feedstocks. Stage 1 is distillation, which separates the primary hydrocarbons from one another.
Crude distillation is the first step in the refining process. This is where we take the raw crude oil that comes in from the crude tanks and we begin our initial separation.
A furnace connected to this tower begins to boil the oil to upwards of 700 degrees Fahrenheit. As the heat intensifies, different hydrocarbon molecules within the crude begin to vaporize at different temperatures. Now separated, these vapors rise within the tower, cool, condense, and are then drawn off at specific levels. The lightest hydrocarbons, like the liquid gases used to make aspirin, rise to the top, while the heavier ones used in motor oils and road materials remain toward the bottom. The result? The once singular crude has been separated into a variety of fractions.
What we get in crude fractionation is these products that you see here. So starting with the lightest product, we have natural gas, which has to be stored under pressure, stored in this container. We have a light gasoline product, a heavier gasoline product called naphtha. We have jet fuel range and diesel range products. We have gas oil range products. And we have residuals like asphalt, or in this case, this is a sample of coke.
None of the fractions that come off the distillation tower are finished products, and all will require further processing. After more than 1 million years underground, most need a good cleaning to rid them of contaminants, especially sulfur.
In this process, we bring the oil in and mix it with hydrogen. We pass it through the heat exchangers behind me and the heater to my left, and we heat the oil up to about 700 degrees. At that point, we pass it over a catalyst, and that catalyst, along with the hydrogen, removes contaminants in the oil before we send it on for further processing.
The result? A clean, contaminant-free product, like this jet fuel. In fact, most airports maintain direct pipelines to local refineries. And as for all that removed sulfur, it's collected and sold as a key ingredient in agricultural fertilizers, in rubber tire manufacture, in fire extinguishers, and even in explosives. But not every fraction is ready yet, and some even need an atomic makeover. Cracking shatters larger, complex hydrocarbon molecules into simpler, more useful ones, which are then made into finished products. This can be done either directly with intense heat or in combination with chemical catalysts.
You can see this is the sort of catalyst we use. It almost moves like a liquid. What we do is we mix this catalyst at very high temperature with the gas oil, over 1,300 degrees, and it reacts to form these lighter products that you see here.
Cracking heavy gas oils into smaller hydrocarbon molecules creates this base oil, used to power ships. In addition, the cracking makes propylene, captured in this canister. Propylene is a feedstock used in makeup, toothpaste, antifreeze, paints, and polyurethane products, including football helmets.
Go.